So this week we're going to take a look at what's called arithmetic sequences. And basically a sequence is just a list of numbers that has a pattern to it. Okay, that's the whole point behind a sequence. Once you see the first few numbers, you can predict the next one based on the pattern that you're seeing. When it's an arithmetic sequence, the pattern has to follow a certain rule, okay, to get the next number. Okay, and I'm going to show you what that rule is. When you write out all the different numbers in a sequence, each number is called a term. Okay, so if I had something like this, 3 would be considered the first term, 5 is the second term, 7 is the third term, 9 is the fourth term, and 11 is the fifth term. Right, so like if I asked you to find the next 3 terms in that sequence, that just means I want you to tell me the next 3 numbers that come after 11. So what makes something an arithmetic sequence? Okay, the way that you get from one term to the next is you have to add or subtract. Right? To be arithmetic, the rule has to be that you are adding or subtracting to get from one term to the next. Okay, so let's look at the pattern that I wrote down. How do you get from 3 to 5? Yeah? You add 2. So if this is an arithmetic sequence, then it has to follow that same pattern every time. Right? If one of them is different, then it's not an arithmetic sequence. But in this one, you add 2, you add 2, and you add 2. Okay? That number that you add each time, okay, even though we're adding it, this is what they call it. It's the difference between the 2 terms, okay, how you get from one to the next. And the reason they call it a difference is because if you take 5 and you subtract 3, what do you get? 2. How about if you take 7 and you subtract 5? 2. 9 minus 11, 2. 11 minus 9 is 2. So if you take a term and subtract the one that came before it, you'll get that thing that's called the common difference. Right, let's look at another one. Okay, so let's say you're not sure how to figure out what you're doing to get from one term to the next. Take any term you want, doesn't matter, just pick one, and subtract the one that comes before it. You should get the same thing all the time. So if you take a term, subtract the one that comes before it, what do you get in this case?
3.
3. So 3 is the common difference. That's the number that you add each time to get from one term to the next. Now, in this case, the common difference is positive because as you go to the right, the numbers are going up. But in this one, what's happening to the numbers as we go to the right this time?
They're subtracting.
Right, you're subtracting, it's getting smaller. So this common difference is going to be what kind of number?
A negative.
It's going to be a negative, right? So let's try one. Just take any number and subtract the one that comes before it. What's 130 minus 135? Negative 5. Yep. So on the front here it says the common difference is, you just put negative 5. Any question why the common difference this time is a negative and not a positive? Okay. So now we've got one that it's got a couple blanks. I think I'm missing one of the ones. Oh, there it is. It's got a couple blanks in it, and they basically want us to fill in the missing blanks. Okay. So the first thing we'll figure out is what is the common difference. Okay. Then we can use that to fill in anything we're missing. Okay, so common difference. It's going to be something minus something. Can somebody give me something I could fill in here and here, and when I do it, it'll give me the common difference? Yep. Yeah, we could do this one minus the one that comes before it. Okay, so let's just use my calculator, type that in, and see what it gives me. So I've got negative 49 minus negative 45. Be careful when you type that in because it's a minus and then there's a negative. So what happens when you subtract a negative? Right, it's really going to become negative 49 plus 45, which is negative 4. Okay, so now that's what we're doing each time to get from one term to the next. We are subtracting 4. Okay, so we go here, minus 4, minus 4, minus 4, and then to get that one, you're going to minus 4 again. So what's negative 53 minus 4?
Negative 57.
Negative 57, yep. Now, what they want us to do is figure out the first term, and that's working backwards. So when we go to the right, in this problem we're subtracting 4. What are we doing when we go back to the left?
Adding.
Yeah, adding how much? Right. To work our way backwards to that one, we're going to add 4. So what do I get if I do negative 41 and then add 4 to it?
Negative 37.
Negative 37. Yep. So any question how we use that common difference to figure out a term that was after, and we figured out one that was before? All right, let's try this one. All right, so it says type, well, we're not typing, we're just going to write it in. The missing numbers. Now, on some questions, they may not ask you to fill in a number. They may just ask what is the common difference. Okay, so that's why I always define that first. Okay, can somebody give me 2 numbers that I can subtract here from that sequence? Doesn't matter which 2 you use. We just have to put them in the right order. That would give me the common difference. Yeah?
61 minus 34. Or 54 minus 64.
So you could do 54 and then subtract the one that comes before it. Yep. All right, so what do we get when we do 54 minus 61?
Negative
Careful, not quite.
Negative 7.
Negative 7. Yeah. So unfortunately, if they ask for what the common difference is and you accidentally put 7 instead of negative 7, it would be marked wrong on like the MCAS. So the common difference is negative 7. So that means you're going to subtract 7 as you work your way to the right. Okay. So now, what would be 47 minus 7?
40.
Yep, it would be 40. But they also want me to work my way back to the left one time. So how am I going to work my way the other way?
You're going to add 7.
I'm going to add 7. So if I take 68 and I add 7, what do I get? Yep, you get 75. Okay. Any question on that? Now, when we number these, let's say that this is the term, and this is the position of the term. Okay. If I was going to make a table, that's a table that shows each number and its position. So 68 is the second term, 54 is the third term, 47 is the fifth term. Okay. Any question on how I numbered each position? So now, let's say that I gave you this and I said, what's the 439th term? Well, we know that to go from one term to the next, as we move to the right, what are we doing each time?
Subtracting 7.
We're subtracting 7. But to get all the way to the 439th term, it's going to take a long time. So we don't, I mean, if I only had to get to like the 8th or 9th term, that's not bad. I can just subtract 7 a couple more times and get there. But to get to 439th term, or maybe even higher, we don't want to just keep subtracting 7. That's going to take too long. So what we want to do is come up with a formula that all we would have to do is plug in the number 439 as the position, and it would automatically give me that number, the term. Right? So that's what we're going to look at now. How can we find a formula that would give us any term that we want to know, even if the term is really, really far away from the ones that we already know. Okay. And that is called a formula. Okay, it's called an arithmetic formula. So using a formula, we can find any term that we want to know. Okay? And you don't have to start with ones you already know and work your way all the way to it. We're going to be able to just jump right to whatever one we want to know. The other thing with subtracting 7 each time, or 4, or whatever it is, if you make a mistake early on, and then you just keep subtracting 4, but you already made a mistake, then everything you're doing is wrong. So that's another reason why, to calculate a term that's far away, we don't want to keep adding or subtracting, because we could easily make a mistake and it messes everything up. Okay, so that is the formula, which I think you guys have printed, that you're going to need to know. Okay, so what does all this stand for? A sub n, right? This little subscript right there, that stands for the position. Okay? So like if you wanted to know the number in the 5th spot, that's the notation you would use. This means looking at sequence A, usually we name a sequence with just a letter, just like a variable. So we call it sequence A, and that means what's the number in the 5th spot. That notation would mean looking at sequence A, I want to know the number in the 13th spot. So that's what that means. So what do you think that means? A sub 1. That's the number that's where? Have an idea? Where do you think A sub 1 is? That's the number that's in what position?
The first term.
The first term, yeah. Okay. When you have A sub 1, that means that's the number in the first spot. So that's A sub 1, the first term. Okay, so that's something that you need to figure out. When you want to use this formula, if you don't know the first term, like we didn't here, you need to find it. Okay? So that's the first term. The other thing that you need to find is the common difference. That's what D is. So that's what do you do each time as you're moving to the right. Remember, to find the common difference, take any term and subtract the one that comes before it. That's how you find the common difference. What else? So we need to find the common difference. You need the first term and the n. Well, when you're writing a formula, you don't fill in anything for the n. That's just going to stay the same. When you want to use the formula, that's when you plug something in. Okay? Like if you wanted to find the 439th term, you would fill in 439 for n. Okay, but that's only if you want to use the formula. All right, so let's see if we can figure out how to write a formula, and then we'll try it and see if it works. Okay, let's try this one. So it says to write a formula for the sequence that's right here. To write a formula, what's one thing that I definitely need to figure out in this sequence?
The difference.
Because I'm going to use it right here. What do I need?
The difference.
Yep, I need the common difference. So let's start with that. Can somebody give me a way that I can find the common difference? And there's a few different ways you can do it, but I want to use these numbers. How about Ben? Can you tell me how I find my common difference?
You subtract, like for example, 19 by 13.
Yep, so we could do 19 minus 13, and what does that give me for a common difference? 6. Okay, so we've got the 6. What's something else that I need to know from those numbers if I want to try to use this formula right here?
First term.
I need the first term. Those are the two things you need, the common difference and the first term. Okay, so we already identified D. I did it up above. And what's the first term in that sequence? 7. So we're just going to take those two numbers and we're going to fill them in up in the formula that I circled. So you've got A sub n, that's not a D and that's not an A1, so we don't change that. The next thing is A sub 1, which means first term. And what did we say our first term is?
7.
7. So we're going to change that to a 7. We're going to have a plus sign and then a D. Plus sign, and you need to change the D. What did we figure out D was? 6. And then after the D is an n minus 1 in parentheses, but the n is just going to stay as n. And that's it. If they don't say to simplify it, that formula is fine. So substitute, I already did that. If they did say to substitute it, does anybody know what property you would have to use with that 6 to simplify that number in front of the parentheses? What is it? Yeah, well, we got to follow, the PEMDAS. But what specifically would we do with the 6?
Distribute.
Yep, you'd have to distribute it, right, if they ask you to simplify. What's 6 times n give me?
6n.
6n. And what about 6 times negative 1? Negative 6. So if I fully simplified that, I get 6n. And what's 7 minus 6?
Plus 1.
That's a positive 1. Okay, so now, if you try that formula, let's see if it works. Okay, so this is the term. Up here will be the position. 1, 2, 3, 4, 5. Let's see if that formula works to calculate the number in the third spot. So let's try it. Let's plug in a 3 for the n. What's 6 times 3? 18 plus 1? 19. And look at what number is in the third spot in our pattern.
19.
19, yeah. Right, let's try it for the fifth spot. What's 6 times 5? 30. And then plus 1? 31. And look at what number is in the fifth spot, 31. So now, let's say you wanted to know the number that would be all the way down in the 100th spot. Okay? I don't want to just keep adding 6 every time. I could make a mistake. So if I want to know the number in the 100th spot, fill in 100 right there. What's 6 times 100? 600, and then plus 1? 601. So if you did this pattern all the way out to the 100th term, you would get a 601 in the 100th spot. So the formula gives us a quick way to find that number. That's what it is. Any question on that one? Okay, so we got one. I think we got one more of those. Okay, on the back. Did I skip anything? Oh, it said use the form. Okay, I did the 100th term. We could have done the 12th term. Sorry, I skipped that. So what was my formula? 6n plus 1. If I wanted to find the 12th term, what number would I be filling in for n? Yeah, 12. Yeah, I'd fill in 12. And 6 times 12 gives me how much? 72 plus 1? 73. So that would be the number in the 12th spot. Yep. Sorry, I missed that. Okay, now let's try the last one. Okay, it says write an expression to describe the sequence below. use n to represent the position. That's the same letter I've been using in the formula I showed you. Let's just copy the formula over from the other page. So what is it? A sub 1 plus d times n minus 1 plus d Okay, what's one thing that I'm going to have to figure out in that formula? About Ava. What's one thing we've got to figure out?
What the A1 is?
Yep, definitely got to figure out what that A1 is. That's my first term. Anyone think they can tell me what the first term is in this sequence? Yeah.
8.
8, perfect. Okay, so we've got the A1. What's one other thing that I need to figure out besides the A1? Yeah,
Difference.
the difference. I got to figure out the D. In fact, that's the only other thing I need to figure out. So to get your common difference, take a number and subtract the one that comes before it. Doesn't matter which two you use. If it's an arithmetic sequence, you're going to get the same thing. Another word you might see sometimes in a question, they call it a progression. Sequence and progression means the same thing. So don't get confused if you see a question that has that word, progression. It means sequence. What's 24 minus 16 give me? Yeah, 8. There we go. So there's my common difference. Okay, so fill them in. I don't know if we got enough room in that. Yeah, maybe we have enough room for the final answer. Okay, let's do it off to the side. So the first term is 8 plus common. Oh, it's just a coincidence here. The first term is 8 and the common difference is 8. That usually doesn't happen, but it could. All right, now, if on IXL they say to simplify it and you type that in, they're going to mark it wrong because that's not simplified. What do we have to do with this 8 on the outside? How about Isaac? What do we do with this 8 on the outside? To try to, we want to simplify this as much as we can. Well, think about when we did it last time. What number was on the outside? Isaac. What number was on the outside when we did it last time? So think back in the last problem, we had a number, and then we had a set of parentheses next to it. What was that number that was right here in the last problem? Okay, let me go back to it. So the number we had there was a 6. And what did we do with that 6? How did I get from this step right here to that step right there? What do those lines above the 6 mean when we write those down usually? Right, we're going to distribute. So can you do the same thing on this one and tell me what you would get? Start you off with 8 plus, because we're not distributing anything there. What's 8 times n? So when you do 8 times n, you just get 8n. What about 8 times -1? No, it's not on the other page, Isaac. Just the arithmetic. What's 8 times -1? Yeah. What is it? Yep, -8. And then when you combine like terms here, you have +8, take away 8. In this case, those disappear. And what's the only thing that I'm left with? What is it? Nope, I'm not left with 8. I'm left with 8n. Yep. So when you write your answer in that box, completely simplified, that's what they would want. 8n.